Accepted.
All right, well, hope that was a good break. Thanks for joining again. So let's get down to the next exercise. Well, it's about streams again. So let's take a look at one more example with streams. So in this example, I have a list and I have a stream, and we call parallel on it. Then we call a map to perform the transformation. Then we have sequential, then we perform the for each, and we print out the result of that. In the transform function, I'm going to print transform, the word transform, and we print the thread of execution. Then in the print function, I print the word print, and I print the thread of execution as well. So to reiterate, we have a stream we called parallel. We are performing the map after the parallel, where we call the transform, we call sequential, and we call the for each and do a print after the sequential. So that's the code. Is your cameras ready? All right, so let's give it a try. This is exercise 6. Let's see what we find. For anyone who joined us after the break, you can use your cell phones and point to that URL, and you can answer those questions. It's completely anonymous. Nobody will know who you are when you answer that. And you can respond to those questions, and we'll take a look at what your response is. I see a few cameras up in the air still, so I'll just give it a second or two before we move forward. I still see a few cameras up, so I'll wait. All right, so let's take a look at this exercise 6, isn't it? So we had 264 responses. The first one, in the main thread only, we have 21% say that, in the main thread only. 20%, almost the same amount, says that in the common pool only. We got 34%, which is higher, who say either main or common pool. And 23% said, please, can I call a friend? So we are kind of pretty split, isn't it, in this? And with a little bit tilt on either main or common pool. What's going to happen? So this is a little bit of a troubling thought here, but when it comes to streams in Java, you want to think about a stream. Remember, a stream doesn't run until you evaluate the terminal function. So when you call the terminal function, it is going to decide how to run the stream. So before that happens, this says, hey stream, run in parallel. And then this says, scratch that. I want you to run that sequential. So the last call actually wins. So when you run the code, the whole thing is in main thread, because the last one says it's going to be sequential. So that's exactly the way to read it. Hey, run in parallel. Oh, you know what? Never mind, scratch that. Run it sequential. If I remove the sequential from here, you will notice it runs in the common pool. But if I keep the sequential, it runs in the main thread. So the moral of the story is that the last call wins. So if I swap these two out, again you can read this. Hey stream, run it sequential. Oh, never mind, scratch that, run it parallel. So you can see it runs in parallel at this point in the common pool thread. So a common thread pool. So essentially, the last call actually wins. Now keep in mind, this the above, right, that is true for Java stream. But for reactive stream, the behavior can be different depending on whether you call observe on and so on. So there are different functions you can call, and depending on the function you are calling, it can be a different behavior. So don't assume all streams exhibit that behavior. Java 8 stream has the behavior that it decides to run either sequential or parallel. There's no segments, or there's no parts of it that run sequential, parts of it that run parallel. That doesn't happen in Java 8 streams. It's either entirely sequential or entirely parallel, decided by the last call that you make, before the terminal call, that is. So that is the behavior of the Java streams and how that actually works. Great. So the next question is going to be about inheritance. No, not that big money you're expecting. This is about the inheritance in OOP. Let's talk about what that is going to provide for us, right? So here is the code. I have a base where the base calls a check function. And the check function is not doing anything. I have a derived which inherits or extends from base. It's got a value which is a string. The derived's constructor is setting the value to the given value. The check function says if value length is 0, throw a new runtime exception, value given is empty. So far so good, right? So now keep an eye on the base. Base has a constructor which calls check. Check doesn't do anything. So just keep that in mind. So the rest of the code is here. We call the new derived with the empty string. So the length of the string is 0. And we call a catch exception, and we print the exception. So the question is, what's the output of this code? Ready? All right, here we go. And it's okay to make noise, okay to ask your colleague. The code? Yep, absolutely. Everybody's using their full power of their CPUs to think about it. So while we are looking at this code, there was a beautiful question during the break. Can we use tools to find these problems? Beautiful question. So I have 3 answers for it. One is, yes, you definitely want to use tools. And tools, depending on the tools you are using, they may be able to find some problems. That's a good thing. I'm a huge fan of unit testing. I love unit testing. I actually use it quite a bit. But you also know that some of the problems we saw, no amount of unit testing would have solved that problem. Unless you knew the problem and you wrote a unit test exactly for it. And even that can be really hard when you have a lot of multi-threaded code. So as much as I believe in using tools and unit testing, I also believe in knowing the stuff. And it can be really hard. You could feed this into a AI tool, and maybe you can find that it tells you the problems, but it may tell you more problems and scare the heck out of you as well. So it's worth, use all the tools you're able to find, no doubt about it. So let's take a look at the response for this, question 7. So we have 287 responses, great. So first, let's see, the 40% of the people said no output, which is kind of scary because 40% of us is wrong. So that's majority, but that's not right. There is going to be an output. 28% said runtime exception. Value given is empty, 28%. So that means 68% of us are wrong, which is even more scary, right? 16% said it won't compile. Actually, it will compile. Yeah, blame it on the compiler, right? So no, that is also not right. As it turns out, 15% said null pointer exception. Really? How many of us love getting null pointer exceptions? Nobody raised the hand, right? No. But unfortunately, when you run this code, what is going to be the output is the question, right? And 15% of us said null pointer exception. And you can see the output is null pointer exception. So what is wrong with this code? This goes to the fundamental of object-oriented programming. And the problem here is that when you called the new derived right there, so when you call the new derived, what just happened? The constructor of base runs before the constructor constructor of the base. So the problem in this case is the constructor of the base runs before the constructor of the derived. This is what happens every single time. So when you do new derived parentheses double quote, it comes in here, but remember, there is an invisible call which is called super, remember? So that super gets called before the rest of the code actually runs. And when the super is called, what happened? The base class constructor is called, that calls the check. But because of polymorphism, it calls the check in the derived class. And when the check is called, the value has not been set yet. The value actually is null right now because it's the constructor that sets the value. We haven't gotten to this part yet. And as a result, if you want to really see this more clearly, let's go back to this code for a second. And here, let's go ahead and say output. We'll say derived constructor called. And let's go over here to the base, if you will. And in the base constructor, let's go ahead and output right there. Just for our purpose, let's go ahead and say this is going to be the base constructor called. So we'll say base right there as well. So when you run the code, notice what the output is. Base constructor called, null pointer exception. So it did not get to the derived constructor just yet. And as a result, that failed. And just to illustrate the point, if I say blah over here, just to emphasize that, and we run the code, it says in this particular case, well, let's see. In this case, we are, pardon me, because it's calling the function in the base, that's not being initialized yet, right? So that is still not being initialized value, so that doesn't help either. So that's being called. On the other hand, just to illustrate this, if I go back and comment that line out in the check and run the code, you can see base constructor called, derived constructor called, and just to illustrate it, check called, let's just to illustrate the sequence of operation, you can see base constructor called, check called, derived constructor called. So that shows the sequence of evaluation. So what's the moral of the story? The moral of the story is in C++, in C++, the base constructor will call the base function. In Java, the base constructor will call the derived function, in the case of overloading, right? So essentially, when you have overloading, but what is common about them? That's the question, right? And the answer is you are doomed in both. So essentially, that's the answer. So the moral of the story is very simple. Do not call virtual functions from within I would say, constructors. So this is the moral of the story, is you shouldn't call virtual functions within constructors. It doesn't matter the language you are using. You're doomed either way. There is no good answer to it. C++ decided to go one way, which is a failure, and Java decided to go another way, which is also a failure. The short answer is you cannot solve this problem because either one is wrong. Because you don't want to call the base constructor, you don't want to call the you don't want to call the basis function, you don't want to call the derived function either. So it's a very precarious moment in the construction of an object. You're not clear what to do with it, and neither one is right answer. So the moral of the story is, when designing classes, we have to be very careful. But of course, the effective Java book has an answer for it already. That's why they say use static constructor functions, right? Static factory methods. Because when you use static factory methods, you are saying, I'm going to make the constructor very ineffective. They just initialize state, and then the method calls other functions. Once the object is baked, then it returns the object. That's the safest answer. So when you want to design your code, make the constructors protected or private wherever you can, and write those static factory methods. That gives you the safety of fully constructing an object before you call any methods on it. So that gives you that relief from problems like this one. So it can be really tricky if we are not very careful with it, so use your judgment. So with that said, type inference again. So let's take a look at one other problem with type inference. So here is a list of 1.2, hello, and new string builder. Then I say list.add new sample. Exception, if there is one, we print it. What will be the output of this code? So let's reiterate. We create a list of 1.2, hello, and new string builder. So a bunch of different stuff that we put into the list. We come back and add to the list. And you're probably thinking, right? Oh, list of, it's immutable collection, which means, well, let's find out. So here is an opportunity for you to respond. So please give it a try. So the list has 1.2, a string hello, and a new string builder that has some stuff in it as well. Perfectly okay to ask the person next to you what they think. It's always fun to compare notes with the person next to you also, right? What did you think? I don't think I see any cameras up yet. So let's go look at the solution for this. Let's see what we responded. Exercise 8. So we had 271 responses. Great. So no output says 21% office. Unsupported operation says 46% office. Null pointer exception, how many people said that? 2.4%. And 29% said it won't compile. And the answer is, it won't compile. Yes. And that's the 30% of us who said it won't compile. So let's try this. Let's try to run the code. Notice I get a compilation error. What's the error? Incompatible types. Sample cannot be converted to intersection type. So this is one of the beautiful things about type inference. It creates what's called the intersection type. The compiler is way smarter than any one of us, in my opinion, with all respect. It definitely is way smarter than me, no doubt about it. What the compiler says is, the type of list is not list of object. That would be too easy. It is really a list of what is called an intersection type. List of what they call as intersection type, where the intersection type is a non-denotable type that is an intersection of all of these. So the compiler is asking, what is common between all of those? That's kind of scary, right? But what is common between all of those? It is extending object, it is serializable, it is comparable, and it is all those three. Now, just to kind of entertain this thought, if you will, notice it's object, serializable, and comparable. Those are the three things. But if you want to add flavor to it, go over here and remove the rest of it. Now let's see what's common between those. And you will notice it is object, serializable, comparable, constable, desk. So that is common between all of those things. If you're curious further, let's go find out what's common between all of those. So in this case, it turns out, in this particular case, the common is number, comparable, constable, constdesk. So you can see the compiler active in determining what the intersection type is. So they took a lot of pain to make this work that way. Why? Because they found out that when people were writing code with different types, they were intending certain operations to be valid, but certain operations to be invalid. So if they were too simplified and they simply used a list object, they would have allowed adding a sample. So just to illustrate this point, if you don't mind, if I go back to this code example here, if I were to simply say in here a list of object like so, then it's okay to add a sample at compile time, but at runtime it should fail. That's when you get the unsupported operation. But that is not what the compiler does. It goes through more rigorous evaluation. So as a result, the code doesn't even compile because you cannot add sample because sample is not serializable, sample doesn't implement comparable, and so on and so forth. So that is impressive amount of effort the compiler does to determine what the type really is. The inference is not just a replacement of a type and go home. It does a thorough analysis of the code to determine that, as we can see. So that's based on the intersection type, as we can see. And easiest way, if people ask me, what is the type over there? I usually make a compiler error. and it immediately tells you what the compiler recognized type is, that's an easy way to find out, right? So that's a non-denotable type. You cannot write code for it. It's non-denotable. You cannot write it, but the compiler knows the type internally. That's what it keeps around. All right, so that's basically just one more thing to think about in terms of type inference. That brings us to list. Let's play with this a little bit further. So I have a list, and I say stream, map, collect. And which is better, to use collect to list or to use to list? To list was added in a much more recent version of Java. I can't remember these version numbers in my head. 12? I don't know. Whatever that number was. But it's more recent, but I love it. So that's the question, and here's your opportunity for response. So please give that a try. That's exercise 9. Make sure you point to the right one. I see just a couple of cameras up yet, so just another few seconds. Okay, so should we continue to use the old function? Should we use the newer function? Let's find out. This is exercise 9. So here we go. 280 responses. Thank you for that. So the blue, 11% of us said, collect to string, I get paid by the number of characters I type. I like that kind of honest response, right? So more code we write, the more we feel employed. That's great. 9% of us said, I have to ask my intern. Interns are great. That's a good idea. That's what interns are for. Hey, go find the answer for this. 37% said they both do the same. 42% said toolless because that involves less typing. Really? Well, toolless is better. So I agree with the 42%, but not because it involves less typing. There is a much more fundamental difference, and I'll tell you why I like toollist rather than collect toollist. Now, this is also a problem here, so let's talk about the evolution of this before we go further. So I have doubled over there. So I want to output doubled like so, and you can see the doubled is 2, 4, and 6. Now, I'm not suggesting you do this, but you could have said doubled dot add 99. Will that work? Yes. So run it, you got 99. But that's not really desirable, right? Yeah, I don't like it. A better alternative to that, I apologize, I think that was Java 12, was collect.to unmodifiable list, right? By the way, I love function names like that. Finally, function names that are longer than my own name. I like that, right? I feel like I'm working with the brother here. That's great. Long names are wonderful. So when I run the code, it says unsupported operation. Why? Because it's unmodifiable list. You cannot add to that list. So the original list is there, but you're not allowed to add to it, right? So that's basically why we got the error unmodifiable, unsupported operation exception. So that's good. Now, while that is great, when you do toollist, the key difference here is this is mutable list. Remember that. This is immutable list. What about this? immutable list as well. So toList creates an immutable list. So you see the unsupported operation exception, so you cannot do this. So the beautiful thing about the toList function is, it's not just less typing. It actually gives you an immutable collection. So that is the behavioral difference between the two. This is why I like the toList function a lot better, because it gives you an immutable list rather than giving you a mutable list. So that's a big win, in my opinion. So my recommendation moving forward is, if you're using collect toList, quit using that. Instead, use the toList function directly. It's less clutter, less typing, but more important, it is much more idiomatic, if you will, because we are creating an immutable collection rather than creating a mutable collection. So that's definitely a big win. Awesome. So most people got it right, but of course it's unfair because my answer did not give the truth to it, but you still got the right answer, so that's great. That brings us to our friendly default. So let's step over to the next example and take a look at it. So I have when, day or night. And I have lights when, and a switch on when. If it's a day, lights are optional. If it's a night, lights are required. And I'm going to say, okay. Should we write the default or leave it out since it's not required? Well, is it not required? Let's run the code to make sure. Yeah, it's not required. Question, should I still write default? Default, I'm going to say whatever, right? Or invalid, or whatever I can throw in here, right? So should I write the default or should I leave it out is the question at hand. So let's see what we think. Here is the next one. This is exercise 10. Looks like most of us have answered it. All right. Let's take a look at what we said. This is exercise 10. So what did we see here? Ooh. Hello. Okay, 282 responses. So write it, but comment it out. I kindly request the 4% to leave the room now. Unimaginable. Gosh. It's okay, you're still among friends. 30% said don't write it. 52% said write it. 30% this is a trick question. I love it. What do you think is the answer? Don't write it. Don't write it. 30% said don't write it. Don't write it. Why shouldn't I write it? Maybe I get paid by lines of code I'm writing, right? So, don't write it. Why shouldn't I write it? Let's talk about the reason for it. If you do not write one, the compiler writes one for you. Isn't that beautiful? So if you don't write one, oh, you know what? Let's do this. Let's go back, run this code, compile it. This is called sample, right? So Java C sample.java, Java P sample.class. Let's just take a peek at it, just to get a feel for it, right? So when you look at it, what do we notice here? Here's the lights, and here's the default the compiler wrote for you. So if you don't write one, the compiler writes one. And guess what the compiler does? It throws a match exception. Isn't that beautiful? So the compiler says, somehow you got here you shouldn't have. I'm going to blow it up. So what is the benefit? The benefit is twofold. The first thing is, let's talk about a realistic or a common situation. What's a common situation? A common situation is, if you have this code the way you wrote it, let's say a month goes by, and the person writing the enum when, in a general situation, is not going to be in the same file, right? It's going to be in a library tucked away. They change it, and they decide to add a dawn and a dusk to it. And guess what's going to happen? Your code will not compile. Because when you recompile your code, you get an error saying it doesn't handle all the path. Now, think about it. Are you better off on that day to know what to do? Or are you better off today to know what to do? Today, you can put some rubbish in there. You don't know what to do. But when the compiler gives you an error, you're like, whoa, there's a new option here. What should I do? And as a good developer, we consult with the business. We go to them and say, what should we do in such cases? And they tell us what to do, and we can implement it. So that is the common case. There is a very rare case that we should also think about. So the common case, you'll get a compilation error, you know what to do, and you do it. So everything is good. If you had written the default, you will not get a compilation error. And because you're not getting a compilation error, the rubbish we wrote will execute for the newer value that's added. And then eventually we get a bug reported, and we got to go fix it. I would rather get a compilation error than a bug report later on, right? That's why I don't want to write it. But a rare case, they modified their enum, but we don't recompile our code. We take their library, throw it in, and simply run the code. Because we don't believe in testing, now we don't believe in recompiling either. So when you run the code, what's going to happen? Suddenly the new type shows up, and it doesn't go through day or night. It goes through default. And the compiler catches that because of the code that was generated, right? Runtime catches that, throws an exception at runtime, and you get a runtime at the exception. That's a very, very rare case, because that would mean we ignore all good practices and throw a library into production and go home, right? And I hope that never happens. But if it were to happen, maybe in a test environment, we'll get that exception. So that's still good. So moral of the story, do not write a default if you're not required to write it. So let the compiler tell you if it's needed. If the compiler doesn't complain, don't write it. That's a better approach. That's the recommendation. Sweet. That brings us to the next exercise. So what does this have? Ooh, records. I love records. So let's talk about a behavior of records over here. So I have a record called year, and the year has what's called a compact constructor, which says if year is less than 0, throw new runtime exception. Year should not be negative. If year is less than 100, this dot year is equal to 2000 plus year. Error, cannot assign a value to final variable year. So in the main, I have created a year 2023, a year 1993, year 24. Why does this code fail to compile? So just to emphasize it, you can see that in this particular code, my keyboard is not responding. There we go. If I compile the code, it says error, cannot assign a value to final variable year. So that's the question. Let's take a stab at it. That's exercise 11. So why doesn't the code compile? I think most of us answered the questions. So let's jump in. So that is exercise 11. Let's see what it tells us. 200 responses. 100 of us are really having, so let me just give a little bit more time then. Just a couple of more minutes. We're still responding, so pardon me. I'll give you a little bit more time to respond. Okay, so what does 11 tell us? We have 47 responses. So the green 9.6% says, dude, you got to upgrade to a newer version of Java. Okay. 15% say you have to write a canonical constructor. 23% of us say this is not accessible yet in the life cycle of the object. 51% of us said record is immutable, so you cannot change year. 51% of us. That's a bit scary because 51% of us are wrong. That's not the reason. So yes, you are correct that records are immutable. But if records are immutable to that extent, you will never be able to create it. So immutability only comes after the creation of an object, not while you are creating the object. So the 51, the first one, the blue is not correct. This one, you have to write a canonical constructor. I highly recommend not writing a canonical constructor. That's not a good idea. In fact, that's something I would avoid doing when writing records is avoid writing canonical constructors. Upgrading Java will not help in this case because the problem doesn't go away in a more recent version. So that brings us to the 23% of us who say this is not accessible yet in the life cycle of the object, and you are correct. So let's go back to this code, and I'm going to remove this dot from here, and I'm running the code, and you can see it worked. So what's happening? I want to spend just a couple of minutes talking about this. This one is called a compact constructor. It is compact, but in my opinion, it's not a constructor. So here's a way to think about it. So think of a compact constructor as a transformer or mapper between the call and the canonical constructor. So think about it as a transformer or a mapper. So you have new of year that you're calling here, and right in between is the compact, you could say compact constructor that sits here, which then gives you the constructor after that. So think of it as a mapper or a transformer that sits in between. So think of it like your map function in your functional pipeline. Its job is to transform data. So this says, I will take an year that you give me, so the value of the year comes in, year value, and what does it do? It transforms year value and then takes year and sets. So essentially, This is the transformation that's happening. That's why you are saying the new value of year is the old value of year plus 2,000. I want to take a quick break here just to emphasize something. In normal programming, if somebody modifies the parameter given to them, you would start screaming. So this defies all logic, right? Because you're literally modifying a parameter given to you. So how many of us in this room know C#? It's okay, you're among friends. I know it too. Okay, a few more hands go up. In C#, if it would make sense to you, you would have called this as ref. It's a reference type, right? We don't have that concept in Java. So you have a reference type, meaning you get the input value, but you can modify it as well. So in Java, we don't have that concept. But in the sense here, this works like a ref, because you are taking this parameter given to you, and you're altering it. So that's why this is a transformation in the middle. So you're transforming the value of year and sending it out. So it's important to understand how this function works. So when I came across this, I was quite baffled. And I'm like, what does that even mean? How does it actually work? And thinking through it, this is the reasoning I can give for it. So think of it as a transformer sitting in the middle, which says, when you send me a value, I can transform it, I can send it out. So don't think of a compact constructor as a constructor. So think of it as a compact mapper, or a compact transformer, or a compact validator, whatever you want to call it, right? It's a little thing that sits between you, the caller, and the constructor. So don't think about it as a construction in that sense. So that's basically the behavior of that particular function. So something for you to dig a little bit deeper into it and think about it. All right. So that brings us to my another favorite function in the JDK, which is the copyof function. So let's take a look at what this is doing. So we have numbers 1, which has an as list, numbers 2, which has a list of. Numbers 1 double equals copy of numbers 1. Numbers 2 double equals copy of numbers 2. What is the output of this code? So that's our next question. Let's give it a try. All right, looks like we are all ready. So let's switch over. This is exercise 12. So let's take a look at it. Oh, only 200 responses. Okay. So what do we, 218. I'll give it just a minute before we move forward. Still refreshing. So just a little bit more time. All right then. So, cool. So we have true and true, 15% of us said. True and false said 19%. False and false said 23%. And 50% of us said false and true. And the 50% of us are correct. So you're right. So majority of us are correct. False and true. Let's see what's going on here. So copyof is very smart because, so first of all, a couple of things for us to keep in mind. Copyof returns an immutable a collection, first of all. If the original is mutable, it makes a copy. If the original is immutable, it returns as is. I want to spend just a minute on this before we go further. So when I run the code, you can see it's a false and a true. It's a false, why? Because the original is mutable, it gave us an immutable version. In this case, it is already immutable. Now, here is one of the reasons why I love immutability. So let's emphasize that here. What is immutable can be shared or can safely be duplicated. This is why I love immutability. What is immutable can be shared. So you have data which is immutable. If it is immutable, nobody can change it once you create it. Guess what's going to happen? You can have multiple references on it. That's very safe. I give you a reference to it. I give you a reference to it. We're all looking at the same data, and it's never a problem. You're not going to complain saying, wait, there was something else a few minutes ago, right? No, it's the same. It's never, ever going to change. So what is immutable can be shared. But here comes the charm. In the world we live in distributed architectures, whether it's microservices or not, doesn't matter, right? It's distributed. Guess what's going to happen? I've got this data. You say, can I have access to it, please? Sure. Here you go. I just made a copy of it and I give it to you. And guess what? Both are immutable. So I can safely make a copy and give it to you, and it's not going to change. And it's very safe to copy. So that is the power of immutability. You can share it, you can copy it, you can distribute it. You don't have to ever wake up in the middle of the night thinking, did I get this wrong? So immutable objects are your friend in a distributed application because it's very safe to share them. And that's one of the nice things about functions like copy-off is that they know the details of what they are working with. If they determine that the object is mutable, they make an immutable copy. But because the object is immutable already, it says, I don't have to waste memory. I'll just give you a reference to it. Why? Because nobody can change it. It's safe to share it. That's why at the reference level, number 2 is the same as copy of number 2. It never really created another reference for you. It just gave back the reference and then call it done. So we saw 12 different examples in here, but as you can see, a lot of these things can be really tricky. When we write code, we got to know what the code is doing. And you can use tools, that's a great idea. You can also write automated testing, that's a great idea. But don't assume just because the code compiles or the code passes through the compiler or unit test or tools, the code is actually good. It's for us to make sure it's really correct. This is one of the reasons I'm a big fan of learning the language, big fan of continuously learning the language. I'm never going to be perfect at it, but I keep discovering these things. And I'm also a fan of code reviews as well, because we can stop these problems earlier on from taking effect, and they can really help us a great deal. I hope that was useful. Thank you so much for joining. Thank you.